ABEC, this word is not quite reliable. Why we still just using ABEC grading bearing, put it into inline? Inline got their own standard. ABEC is not enough. Our concern, our requirement, our spec is way far beyond the ABEC. Because we're concerned about the clearance, the design, the material, right. Not just only accuracy. The ABEC, the chart, you can see SKF put down the ABEC. What is called ABEC 1, 3, 4, 5, and all the damn numbers that nobody can understand all the numbers. Of course, ABEC 7 is better than ABEC 1, but ILQ 9 is only got one standard.
Right.
The best standard.
There you go.
No comparison. Low margin for error. A good designed 6-ball can handle higher loading, higher than ABEC. The Baker ball got a different race weight, can provide even less friction. Less friction, that means more free spin. You believe it, you buy it. You want to test it? Okay, I give it to test. I got data, I got numbers. Material what using, ABEC didn't mention about. That's why in the whole market it's getting more and more, getting down all the materials. You understand what I mean? Nowadays, you know that some of the bearing is chrome still outer ring, carbon still inner ring. There's nothing governed, no rule. If you are interested, take some time to go buy some other brand name skate, take it out the bearing, check it out, go to the lab to test it, give it a result. I think a lot of consumers will shock about that. 99% of the bearing come from China.
Right.
I think twin cam is the only one to show you my work process is really serious to produce inline skate bearings. If you go compare with some other people, you're scary. Don't you think so?
Data in there.
I got a lot of data, technical data. 6-ball is very difficult to design. Higher loading rate. Friction ratio is less. I got all the data, I got everything from the lab. Okay, the ball is bigger. In here, in the thickness, it's only 7 mm. So it's very, very accurate to put the 4.5 mm steel ball inside. Standard 7 ball is 3.969. All in here. I also got the data in here that you can put it into the CD. The ball is bigger. 6 ball is bigger. That means inside the bearing, the space, the volume is less than 7 steel ball. We can put less lubricant inside. Less lubricant, more free spin. Everything makes sense. 6 balls. On the other opposite side, it provides better free spin, loading. In 2 years, 3 years experience, OEM didn't pick 8-ball bearings. A year ago, I talked with my engineer. I asked them why people doesn't like 8-ball, and they say that 8-ball is not that good. Then I say, okay, what about 6 balls? I said, try. We're using import retainer, thinner. The retainer, the steel is thinner to save a space to fit the 4.5 mm steel ball, put it into the 608 bearing. If put a shoe in here, this one is this size open. We put down a whole lot of high technology into ILQ. Air conditioning 608 cannot be put into vacuum cleaner. The reason is that 2 different applications, they got 2 different requirements. Vacuum cleaner, very high speed. Air conditioned bearing, very quiet. Same 608. So we need to have 2 different design. Why we still just using ABEC grading bearing, put it into inline? Inline got their own standard. This is my standard. This is the inline standard. Tom and I make the inline standard. It's a new rule. Why? All the market using ABEC 7 bearing. I mean the ABEC 7 gradings got no use because here it's only got ABEC 3 or ABEC 5 dimension. If I put the ABEC 7 dimension into an ABEC 1 hub, got no use. You pay for ABEC 7 outer ring, but you're only using the ABEC 1 tolerance in here, because see, this one is only injection molding. I'm put it in. If this one is only ABEC 1 grading or non-grading, put it in, you got no use. Got no use. You're wasting the ABEC 7 grading costing. That's the point. Any question? Talk about grease. OEM using grease because it's a little bit thicker. I mean, protect the brand better. The razor using oil because they think it's faster. What? Oil plus thickener, it make grease. There is thousands of different agent or different material to put into the oil to make a grease. I'm using the Kyoto grease. It's using lithium as a thickener. Some of them using clay, even clay, as a thickener. Mobile oil, some of the people. Thickeners depends on what is your application, what we put it into a very heavy machine. Lithium is very good thing. Lithium can handle very high, heavy loading. The most function that grease using is for lubricant, to cover up all the contact point. The function of the grease is try to bring out the heat. If you put the grease with the same oil, same chemistry, we still keep using it until a certain temperature, revolution, the performance is the same. TK gel is absolutely water repellent. I make the TK gel by myself. Water cannot dissolve into TK gel. Oil still got certain free spin for certain period, but dry out. Lithium, the thickener is still holding up the oil. You can buy a car, buy a BMW without putting any engine oil. You still can run for a certain period, not according to the proper maintenance. We are talking about how to maintain the bearing and then provide the bearing into the very best performance. Here's the build up, it's very dangerous. The steel ball expand. If the steel ball expansion is greater than the raise, then it seize up the bearing. Going downhill like you were in Hong Kong, you fell down. When you spin the bearing, the TK gel will go inside. I mean, he spin inward. If your bearing, the lubricant just get into the inner raceway, you form a layer of insulation. Free spin without loading doesn't count. Doesn't make sense. It's not fair for the consumer spin the wheel to check it out. Is it a good bearing or not? Very wrong. It means nothing because the bearing put it into the wheel. If everything is not compatible, the wheel, the spacer, the frame, the bearing inside misaligned, then the bearings cannot spin. That means the outer ring is governed by the hub, right? The outer ring is at a fixed position. Spacer are longer. Then you pull the inner ring outward. Free spin on the shelf is a joke. All the salesmen tell, oh, see how smooth spin on the shelf. It's not fair. I can give you very light oil, put it into your bearing, and then you can spin forever. Everybody knows that. All the buyer, everybody knows that. I mean, free spin doesn't count, but what about all the consumer, all the little kid? I designed the first undercut bearing for E9. Here is undercut.
What, right here?
The L, like L shape.
Oh, okay, that's undercut.
This is a little bit smaller, the interface with the bearing. See how there's a step there. It's impossible to see light through any Tom's bearings.
I got a free spin machine in my factory. I test every single bearing. And I have a string in here and pull down a weight in here. 1 meter string with 300 gram weight. And then let the bearing free spin until it stops. Show you the free spin test report. The ABEC 5, the average is 37 seconds. Twin cam TK gel 55 seconds. Very light oil 52 seconds. My racing oil bearing 105 seconds.
Case closed.